All right, welcome back everyone. Let's go ahead and get started with lecture 2 here. Today we'll be covering variables, input, and output for simple programs. So by the end of today's video, you should really be starting to get more comfortable with writing simple C++ programs. So our goals are to go through and take a look at the main parts of each C++ program. So we'll go through piece by piece, line by line, and understand what each part of our program is doing. Next, we'll start learning about proper C++ syntax and best practices for formatting your own C++ code. And finally, we'll start writing some simple C++ programs that use variables, inputs, and outputs. If you're following along in the Gaddis textbook, this comes from chapters 1 and 2. Let's start with a little bit of review from our previous video. See if you remember the answers to these questions. In the past, similar questions have appeared on quizzes and exams. Go ahead and pause the video for a moment if you'd like, and see if you remember the answers. Then you can resume the video and see if you got these questions right. So first question. C++ is called C++ because plus means +1. Number 2, C++ is considered to be a high-level programming language. Remember, high-level programming languages use words and language that we understand, whereas low-level programming languages are used to talk directly with hardware. Number 3, a CPU can only understand machine language. This is language written in zeros and ones, or binary instructions. Number 4, probably remember that a compiler and linker are needed to translate C++ into instructions that the CPU can understand. Number 5, the smallest unit of memory is the bit. Remember, 1 bit is a single 0 or 1. A byte is a set of 8 bits. And finally, you may remember, when running, programs are kept in the main memory, also known as RAM. Make sure you remember those key terms. All right, and also make sure you're familiar with the hardware concepts we covered last time. Again, this is not a hardware class, but you do want to make sure you remember these general terms about computer hardware. And if you have any other questions on these topics, remember you're welcome to reach out. Okay, let's go ahead and move on. So we're going to go ahead and start out with algorithms and simple programs. So question for everyone. Has anyone heard of Nailed It? Nailed It is a Netflix baking show where terrible bakers compete to see who is the least terrible. And this show is a very lighthearted show, and people tend to just be very cheerful and have fun while they're baking. So it's not meant to be hurtful in any way. But you'll find if you watch the show, one of the main things that happens is the contestants don't follow the recipe, or not enough instructions are given. And what happens is the contestants try to bake a nice cake, but instead they end up with usually an ugly result. here you can see, compared to the one in the picture, the final result, the frosting color was not quite right, and the cake is kind of tipping to one side. Maybe the frosting was applied when the cake was too hot and it started to melt. So clearly, following a recipe and having detailed instructions is critical. And you wouldn't want to try to bake a nice cake like this without a detailed plan. And the same is true for programming. When we're writing our programs, as much as possible, it's a best practice to start with a plan. Many students like to dive in and start programming right away, but you'll find that if you take some time at the beginning to put together a plan, it will help you avoid a lot of errors and end up saving you time in the long run. And believe it or not, this is actually what happens in industry as well. Programmers and engineers typically follow a process like this. Typically, in the first part of the programming process, we call it the problem-solving phase. This is a planning phase. This is where we figure out what our program needs to do. We make a plan that's as clear and specific as possible. And we try to plan out, okay, what are all the things that our program needs to do? What detailed steps must we follow in order to complete our task? If you compare this to the engineering design process, you see there's a lot of overlap between clearly defining your problem and clearly defining what your program needs to do. Once you've come up with a detailed plan and you've decided how you want to accomplish that problem, then you move on to the second phase, the implementation phase. This is where we actually write and debug our code. And so notice there's also some steps within the implementation phase. We'll need to first write our actual code and run it, and probably we're going to run into some errors while compiling. Perfectly normal part of the process. So then we have to correct those compiler errors, but we're not necessarily done. Just because the program compiles and runs does not mean it's working correctly for all possible cases. So what happens next is we usually test our program with sets of known data, and we verify that the program produces the expected results that it's supposed to. And more often than not, there will be some errors in the program that need to be corrected. So testing is a very important part of our programming process. We need to run that test data and correct errors that we discover. The last step is the validation step, where we make sure that the program is producing correct results for all the expected inputs and use cases that we see. So notice it's very important that you start out with a good plan, because the last thing you want to do is have to go back and redo your planning and your algorithm. Or if you miss some important part in your algorithm, you may run into a lot of errors when you try to test and implement your program. So let's take a look at an example, just a simple one. Suppose we wanted to write an algorithm and a program which calculates pay. So we're asked to write an algorithm and a program which prompts the user for number of hours worked and hourly pay rate. The program should multiply hours and pay rate and output total pay in dollars and cents to the screen. So for now, let's just think about the algorithm part. And over the course of today's class, we're going to learn all the skills we need in order to actually program and implement this program. And when you're first starting to write an algorithm, you might think, well, oh my goodness, where do I start? One of the best tricks I recommend to students is to work backwards. Start with what the program needs to produce at the very end. then you can do a bit of reverse engineering. Work backwards to figure out what other steps need to happen in order to complete that task. So let's go ahead and give this a try with this algorithm. And if you'd like, you can also pause the video and try writing the algorithm yourself. And you can compare your result to mine. You'll find there's really no wrong way to write an algorithm. There's many possible ways to do it. The important thing is you want to be clear and detailed. It's as if you're teaching a computer how to do something for the first time. You want to be careful what you assume. So remember, a computer will think a little differently than we do. So let's go ahead and give this algorithm a try. And I'm going to try using that strategy of working backwards. Okay, well, we know what our end result must be, right? We know at the very end of our program, we need to output the total pay to the screen. So I'm going to write that at the bottom. And we want that in dollars and cents. Okay, so that's good. We want to output to the screen. Well, now what do we need to do in order to output our total pay? Yeah, we need to calculate it, right? Let's calculate our total pay. And we may even need to store that total pay in some variable in order to output it. But how do we calculate total pay? Well, we do that by multiplying the number of hours times the pay rate. Oh, well, wait a minute. Now, where do we get number of hours and pay rate? Well, often in programming, just like in math class, we may use some variables. So I'm going to decide to create some variables named total pay, number of hours. Let's just call it hours worked, and pay rate. So we'll use those variables to hold the values from the user. Okay, well, that's giving us some more hint about what we need to do. In order to actually determine total pay, we need to find out what hours worked and pay rate are. So in order to do that, we need to ask the user, output a message asking our user for, in this case, let's say pay rate. And then we need to store the user's pay rate in the pay rate variable. And similarly, we got to do the same thing for hours worked. So we got to ask our user for the number of hours that they worked. And then we store the user's hours worked in the hours worked variable. Well, wait a minute, where do those variables come from? Turns out in C++, we actually need to tell the computer that these variables exist. We have to declare these variables. we'll cover more how to do that a bit later. But an important step would be to declare variables to store total pay, hours worked, and the pay rate. So let's just declare those variables. Total pay, hours worked, pay rate, and these variables need to be able to store decimal numbers. So we're almost done. Notice we have almost everything we need. The last thing we'll need to do is make sure that our C++ program headers and to make sure our program includes headers to enable inputs and outputs. And if needed, we can format decimal numbers. So there you have it. This is one example of an algorithm that you could use for writing this pay calculation. And this might have seemed like a lot of extra work, and this seems so simple, right? Like a lot of students might have been able to just sit down and write this program from start to finish. But imagine if you were trying to do something a lot more difficult than this. Many of the assignments in this class and programs you'll write in the real world are going to be significantly more complex. So mapping out this plan is so important in order to develop a program successfully. And now that we have this algorithm, you'll see it's actually pretty straightforward to figure out what our program needs to do. We basically just need to learn how to declare variables, how to do inputs and outputs, how to perform a calculation, and how to output stuff to the screen. Let's now talk about how we actually learn to do each of these things in C++. By the end of today's lecture, we'll have everything we need in order to implement and run this program. So once again, here's another possible solution. So there's really no right or wrong answer. Every student will write algorithms differently. But you want to make sure you are as clear and detailed as possible. Another actual strategy that is helpful for beginning programmers is to actually write the algorithm as comments in your program. So we'll demonstrate this a little later, but you can see that if you actually break down your algorithm into comments, then it can help guide you through the programming process. And it can make it a little bit easier to implement that program and follow what's happening. So let's go ahead and learn about how to accomplish all these different tasks. And then at the end of today's class, we will implement this program from start to finish. So this leads us to our key takeaway number 1. Key takeaway number 1, write a detailed algorithm before you start coding. It will save you time. Remember, working backwards can help with planning, and you want to make sure you keep that algorithm detailed and include all the relevant steps. It may seem like a little bit of extra work, but it will save you time later. Let's move to our next point. It's very important that you understand the basic elements of a C++ program. Let's go through an example line by line and show what each element does. So first, one of the very first things you will see in a C++ program are those include statements. So these are called preprocessor directives. What these do is they add what's called library files to our programs. So in the case of include IOStream, this adds the library file for inputs and outputs. So basically, this will make sure that when your program is compiled and run, it also includes the files needed to use statements like cout. And we'll learn later in the class that we can also create our own library files, and we'll do that later when working with objects and classes. In this case, IOStream is built into C++. One other thing to note, notice that we do not put a semicolon at the end of that include line. There's no semicolon here. So be careful, no semicolon after that line. Next element is the using directive. So the using directive adds a namespace, which is a collection of defined names. Basically, it's a naming convention. In our class, we typically always have using namespace standard in our programs. This means we are using a standard naming convention. If you go into industry, you might have some other naming conventions you use, and you might use a different namespace. For our purposes, for this course, we almost always will have using namespace standard in our programs. This line is also required in order to make the names cin and cout available in our program. If you do not have this line using namespace standard, then you might see that programs will have to include something like this. And that's because we have to specify what naming convention we're using. But for the purposes of our class, we almost always need to have using namespace standard. In our program. So for now, for all those simple programs you're writing, always include that line. As you get more advanced, you may use other namespaces. Here, we include this. Next element is our main function. So every C++ program must have a main function. So the main function is this whole piece here. And that, you can see, it includes all the program's statements. So these are basically all the things that we want this program to do. Notice the main function is enclosed inside a set of curly braces. And at the end of the main function, we put return 0. Once again, the return 0 is used to indicate that this program completed successfully. Also, please note that every C++ program must have a main function, and there can only be one main function per program. Later, we'll cover how to write different functions for your program, but there can only be one main function. All right, our next element is comments. And you can see here we have some examples of comments in our slide. So comments are lines of code that are ignored by the compiler. And you might think, well, if the compiler ignores them, why do we need them? Comments are very important. Programmers use comments to make notes and add annotations to programs. You can imagine if you have a program with thousands of lines of code, it can be very helpful to see comments to remind you what each part of the program does. Later in the class, we'll talk about more situations when you absolutely want to include comments in your code. Another nice thing that comments can do is they can be used to cause the compiler to ignore sections of code. So if you're trying to debug and you want to comment out the code that's not working, you can actually use a comment to basically temporarily disable that line of code. You can try running the program without that code and use that to help pinpoint where your error is happening. So one thing to note about comments is that a single line comment uses just 2 slashes, and if you have multiple lines, then you can enclose the whole section with the slash and asterisk. All right, a couple other things to know about programs. These are a few key terms you should be familiar with. Often these words pop up as we're talking about programs and as we're diagnosing error messages. First component is a keyword. Keywords are words in C++ that have a special meaning, and so we cannot use these words for any other purpose. For example, if we look back at our previous program, you'll see words like int or main. These are keywords. C++ needs these words in order to run, so we can't, for example, name a variable main or name a variable int, because that would confuse C++. Next is programmer-defined identifiers. So these are names that us programmers make up in order to represent things. So we can use identifiers to name a variable or a function. It's just a fancy programmer-defined identifiers is a fancy way of saying names that we make up. Next is variables. A variable is a named location in memory, and it's used for storing data. And notice we must declare that variable first before we can use it. Notice here, defining a variable is actually giving a variable a value that can be done later on, but you always have to declare a variable before you can use it. Next is literals. Literals are different than variables in that literals are values written directly into the program's code. So instead of having, say, something like number equals 3, we'd simply have the value 3 written in. And this variable number, we could change that to something else, but if we have a literal, that is something that is hard-coded. We cannot change that value except by changing the source code. So variables are values that we can change over time, but a literal is something that once it's coded into the program, it's fixed, it cannot be changed, unless we, of course, go back and change the source code. Next element is operators. So operators are used to perform operations on data. And so there's many kinds of operators like plus, minus, multiply, and even assignment for assigning value. Finally, last two items are punctuation and syntax. These are basically like grammar rules for our program. So punctuation are characters that are used throughout the program. For example, a semicolon, which marks the end of a statement, or braces, which enclose a function. And syntax is the general grammar rules that must be followed. So we'll see, for example, that we put one line of code or one statement per line, that we have to end every statement with a semicolon. These are examples of syntax rules. All right, let's move on to our next key takeaway. Next key takeaway is that you always want to follow the rules and best practices for programming format. You want to make sure you build your good habits now. So, engineers and programmers kind of stereotypically, we're not very good at English class, right? Like sometimes we can have poor spelling, poor grammar, but in programming, programmers are very picky. So programmers are very picky about style and format. So please note that you want to use good practices. You want to follow good practices. Because if you don't, otherwise, you will appear sloppy, unprofessional, or inexperienced. So don't be that person. You don't want your coworkers to not like you because your code is sloppy. So please pay attention to these good habits in the next slide and start developing these good habits now so that they come intuitively and naturally to you in the future. So let's start with a few general rules and best practices for style. Notice this first rule. All commands, so these are all the statements in the main function, they must end in a semicolon. Notice our cout statement and our return statement, both of those end in a semicolon. Notice that comment and the declaration and definition of the main function do not have a semicolon. Those are exceptions, but generally any statement that is actually performing a task, that will have a semicolon. The semicolon tells the compiler that it has reached the end of a command or statement. So you have to have that in there. The compiler needs it in order for the program to properly be compiled. Also notice that the include header does not get a semicolon. So that one is another exception. Another rule is that functions must be enclosed in curly braces. And so you start with an open curly brace and end with a closed curly brace. And good practice is that the first curly brace start either next to here, next to main, or on its own line, and the second curly brace should be on its own line. Another general rule. Variables must be declared before they are used. We'll do some examples of this a little later. And then finally, we need to make sure we use these include headers in order to find various library files and information we need. So here we have to use include IOStream and using namespace standard in order to do our output. Other good practices. So another very important practice is braces. So you want to make sure you place the opening and closing brace on a line by themselves. The opening brace can also be placed up here. So the opening brace can be placed right next to the function. Some programmers prefer to do that, but either way, the opening brace must be either up right next to main or on its own line. And then the closing brace must be on its own line by itself. This improves readability. And soon you'll see that if we have many braces in our program, many statements within statements, it can become very important to easily see which thing is inside which braces. Next, notice that we have indented all the statements inside our braces. This is another big thing for readability and a very good coding practice to follow. Next one, generally we want to use no more than 80 characters per line. So if you have a very long line of code you're trying to output, you'll want to split that line into two if you need. If you have a lot of code, you can split that line of code into two. The reason for this, again, is readability. You want to make sure your code is easy to read and that none of it appears cut off. This might seem like a little bit of a nitpicky rule, but in industry, actual companies will have this rule in place and expect you to follow it. Lastly, you want to use comments to explain what you're doing, and especially when you are doing something that might be a little more unique. So you do not have to comment every single line of code, but it's a very good practice to put comments here and there to explain what is happening and help make your code easier to follow. Also, we want to use comments when committing and pushing to GitHub, and we'll cover examples of that more in our assignments. Key takeaway number 4, let your IDE help you. Programmers use IDEs for a reason. Remember, IDE is an integrated development environment, and it's designed to be an all-in-one program to help you write, compile, debug, and run your programs. So it turns out that in the CLion IDE, there's a very nice feature called Control-Alt-L, or reformat code. And if you use this command in CLion, it will automatically do its best to format your code following these practices. So it will indent your statements, it will place your braces only on one line, it will do its best to make your code formatted nicely. So, very good trick whenever you're about to submit an assignment. You can try doing Control-Alt-L, look through your code, make sure everything is formatted nicely. You would want your instructor, your boss, or your coworkers to be reading nicely formatted code. Another nice shortcut, if you want to comment or uncomment sections of code, you can use Control and the slash key. This is the same one as the question mark. So you can use that key to quickly comment or uncomment sections of code. All right, and remember, if you do have questions on these points, feel free to reach out. Got a few more key takeaways to cover, and then we'll be ready to write that program. Our next key takeaway today is that we want to use this command called cout. So notice it's not pronounced count, it's pronounced cout. Cout is used to display text to the screen. Notice my asterisk here. It requires the include IOStream header and using namespace standard. So these are required. in order to use the cin and cout commands. So make sure, pretty much for almost every program that you'll write in this class, you need to have include IOStream using namespace standard. And so notice here in this sample program, you see that we used cout to output hello world. And so if we were to compile and run this program, we would see exactly that. This is also a good example of something that has been hard-coded into the program. We're not able to directly change this hello world output unless we go back and modify the source code. So here's an example of using cout in that pay calculation program. So notice if we want to ask our user how many hours have they worked or what is their pay rate, or if we want to output the total pay to the screen, notice we can actually use cout statements here in order to output that data. Next important point, using escape sequences to format our outputs. So this is very important because we don't always just want to output text directly to the screen. Sometimes we need formatting, like tabs or new lines or other types of characters. And so we use what's called an escape sequence to help us format our outputs. And this table lists some of the most common escape sequences that we use. So let's quickly demonstrate one example that's very common. It's this pay calculation example. So if I were to write our cout statements as shown in our previous pay calculation, you'll see that all the lines are outputted on the same line. Right? Notice we have how many hours have you worked, and then notice, so our first cout is here. Then the second one, what is your pay rate? That's immediately outputted on the next, just immediately to the next part of the text on the same line. And finally, the total pay outputs are all on the same line. That's not very readable. And so you'll see, instead of outputting that way, we can add this \n, or we can use ENDL. We can use these to make the output appear on a new line. So notice in this case, the \n, that will create a new line after the output. So we'll output how many hours have you worked? And then notice the new line. And then the next, what is your pay rate, appears on the next line. And then we output what is our pay rate. We have another new line, so the next output starts below it to give us the total pay. Let's go ahead and take a moment to demonstrate this in CLine. All right, so let's just briefly demonstrate this example for everyone's reference. So you can see here, we have our code as shown in the slide. We have our IOStream header using namespace standard, And notice we have these cout statements. Also notice each cout statement has a semicolon, and if I forget that semicolon, I get some messages from sea lion asking me for that semicolon. So let's make sure all our semicolons are present, and now we can go ahead and run. So I'm going to just run this example. And notice in my output, I see the output is all on the same line. But if I instead put in what's called those escape sequences, like the /n, this will create a new line. So if I put a new line right after how many hours have I worked, but inside the quotes, notice now, before my next output, this next line will appear on a new line of text. So I can similarly notice the /n must appear inside the quotes in order to work. Oops, let's do /n, not /m. So if I put both of those escape sequences in there, notice now each line appears on its own separate line. An alternative way that others often use is instead of using the /n, you can also do end line like this. It does the same effect. It basically just ends this line. So you see, if we use end line, that will also produce the same output. Notice if you use the end line, then you just have to make sure that that is not included in the quotes, but you do have to have another operator here between your quotes and the end line. All right, so let's continue on with a little bit more about using cout with variables and text. So you can also use cout statements to output values of variables and also different kinds of text. And one important thing to note is that the statement in the text is outputted exactly as put in the quotes. So notice here, if I have a space, that space will also be present here. So you want to be a little bit mindful of your inputs and outputs. And in this case, if we want there to be a space between our text and this variable, notice here if num apples is equal to 2, we're basically outputting the number 2 here. So we want to have a space between the colon and the 2. So we do include an extra space before the quotes so that that space will be present in the output. Let's try another quick practice. Suppose we had this code. So assume that all the headers and main function are present so that it would run as intended. Take a moment and think, what output would you get from this code? Pause the video if you'd like and think about it. All right, let's go ahead and take a look at this code line by line to see what happens. Notice choice A would be incorrect because we have /t, this is a tab, and we have /n, that's a new line. So the output will not appear all on one line. In choice B, kind of have the right idea, but notice there is no new line between happy and this second line. So in fact, the correct output is choice C. Notice just because the cout statements appear on separate lines, this doesn't make the output on separate lines. So in this case, notice this first cout statement, happy. That's our first statement. Then our next statement, we have a tab, and then another happy, and then a new line. So this is our second cout statement. And then finally, our third cout statement is 2 tabs. So 1, 2, let's use a brighter color. And we see that there are 2 tabs. And then happy, happy. So notice that we have to have a new line. So either a \n or end line like that in order to make our code appear on separate lines. All right, so if you have any questions, remember you're welcome to reach out, and I encourage you to try playing around with the example code that we just showed. Let's move on to variables. And let's start with a random fact. Did you know that in New Zealand, you can't name a baby for real 89 or a second? And believe it or not, people actually tried to name their children these names in New Zealand. But the New Zealand government actually said they could not do that because names could not contain values beginning with a number. And so you can see actually in this old BBC headline that the couple, they wanted to name their kid for real, but they ended up being forced to name their child a different thing, so they decided Superman instead. So this same rule actually applies in C++. You can't have a number for the first character of a variable's name. So please remember that as we start to cover variables. Rule number 7. We do want to make sure that we follow all of our variable naming rules. So first naming rule, we want to use useful, precise, and meaningful names for our variables. The term here we say is that we want variable names to be self-commenting. What that means is that it should be obvious what kind of data that variable holds. It should be easy to tell what data the variable holds. You want to make it easy for your classmates, colleagues, instructor, or fellow programmers to understand. For example, things like this: final value, username, number of runs. It's very clear what that variable is holding. If you simply name your variable n, number, x, these are not very descriptive. In fact, if I were to see a single letter as a variable name, generally I would deduct points for that because that's not a good practice. You want to make your variables descriptive and easy to follow. Another good practice is if you have a variable that has a slightly longer name, you can squish the words together. For example, number of runs becomes number of runs. And notice you can capitalize the first letter of the squished together words. Next naming rule. The first character must be a lowercase letter or underscore. It can't be a number. So you cannot have a number or a capital letter as a variable name. So please follow that rule. And the remaining characters of our variables must be letters, numbers, or underscore. So you cannot have special characters, punctuation. It needs to be letters, numbers, or underscore. Last variable rule. You cannot use keywords or reserved words for a variable name. So here is a list of some C++ keywords or reserved words. These cannot be used for variable names. I mean, you can imagine if you tried to name a variable true, then your C++ compiler would have trouble distinguishing the variable true from a true value. So you'll actually get a compiler error if you try to name a variable one of these words. All right, so finally, next point to remember, you cannot use a variable before it is declared. So make sure before you use a variable, you always want to declare it. And it's actually very easy to do this. All you need to do is state the type of the variable and then the name. So the syntax looks something like this. You have the type name, which in this case is an int, and num students is the name of the variable. So this is the name that we give the variable. In the second example, we have double average mean total score. So here we are declaring a variable of double type. And we're declaring 3 doubles. So here we have average, mean, and total score. So you can use this syntax to declare 3 variables at one time. A couple more things to note about declaring variables is you can declare the variable either at the beginning of the main function, or you can also declare the variable right before you're going to use it. As long as the variable is declared before it is used, then you're okay. We use this term called scope to describe the part of the program in which the variable can be accessed. So variables are available to use after they are declared, but only available inside the braces where they are declared. So in this case, notice the braces define the boundaries of where that variable exists. So here, if we declare sum is available in this area, or until we reach the closed brace. Let's do a couple quick examples. So if you'd like, you can pause the video and give this a try. First one, how would we declare a double variable named hours worked? Yay, that kind of sounds like what we need to do in our sample program, doesn't it? Well, to declare the variable, we just say the type name. So we have the type name and then the variable name, and then a semicolon. So in this case, we would say double, have a space, and then hours worked. Next one, how would we declare 3 double type variables named hours worked, total pay, pay rate? Well, we could do it in a single line. Or we could say one on each line. So either of those would be correct. Declaring the variables on individual lines might be helpful if you wanted to initially assign a value to one of them. So here's how that could look in our code that we saw earlier. If we want to write that pay calculation program, we would want to declare those variables toward the beginning of our program before we try to actually use the variables. All right, next key takeaway. Make sure you use the correct data type when declaring variables. In the previous section, you might have been wondering, well, what's an int? Or what's a double? Or why would I choose an int instead of a double? So you don't need to memorize all these details about size and bytes, but you should know, in general, what each type of variable is designed to hold. So an int type variable is used to store integers, or whole numbers. Notice you cannot have a decimal. You cannot fit a decimal in an int. Ints are for whole numbers only. If you do have a decimal, then you want to make sure you store that variable in one of these other types, like a float, double, or long double, and notice the precision is different. We call doubles doubles because they have double the precision of a float. Notice double has 15 digits of precision compared to less for the others. And finally, we have chars that are used to hold a single character. Some people call it char or char. Either pronunciation is good. Bool variables hold either a true or a false. And finally, a string. Actually, this is technically strings in C++ are classes, but a string can be used to hold text or multiple characters. And generally, when we're working with strings, we want to use the include string header in order to access functions. We'll cover that in more detail later. So the important thing to remember for now is that you want to store your data in variables of the correct type. So make sure if you want to store a whole number, you declare and use an int variable. If we want to store a decimal number, then we need to declare and use a decimal type or a decimal holding variable. Most often for this class, we will use ints and doubles. Next key takeaway, number 10. We want to use cin. Notice it's pronounced cin, not sin. We use cin to get inputs from the keyboard and store them in a variable. Here's the thing about cin. Cin will read data until a white space is found. And then this little thing here is called the extraction operator because it's basically grabbing the data from the keyboard. And once again, you do need to use include IOStream and using namespace standard in order to use cin and cout. So let's take a look at an example of cin with our pay rate program. So now we have our variables, hours worked, total pay, and pay rate. We can ask our user, how many hours have you worked? And notice we can use cin hours worked to take the data in the keyboard and store it in hours worked. Similarly, we can ask our user for the pay rate and use cin pay rate to take whatever data was given for pay rate and store it in the variable pay rate. And then finally, all we need to do is do a little math. Total pay is hour work times pay rate, and we can output to the screen. All right, so let's go ahead and finish this program. So I'm going to declare some variables. And you might be wondering, well, why am I using double here? Well, we don't know what input the user is going to give us. It could be a decimal. Maybe they make $10.50 per hour. Maybe it's a whole number, like $20 an hour. We don't know for sure, so we want to be able to take either decimal or whole number inputs. So we're going to go ahead and use double as our variable type. So here we've declared our variables hours worked, total pay, and pay rate. Next, we outputted our message to the screen asking our user for the number of hours worked. So after we ask them, we want to store that value into hours worked. And notice CLion is kind of popping up the variable name. It's trying to help me as I type in that variable. Next one, output message asking for pay rate. So same deal, right? We ask our user, okay, what's the pay? And then notice we can take in cin pay rate. And I need to include a semicolon after. And then finally, notice I can calculate total pay. Total pay is just going to be hours worked times pay rate. And notice here, for my output, I can just do that, and that will output my total pay to the screen and just leave a new line afterward. And notice now we are ready to go ahead and run this program. So let's go ahead and run it. So how many hours have I worked? Notice the program has paused. It's waiting for me to give an answer. So here I can say 40 hours, and notice if I put spaces, it just will end up ignoring those spaces. What's my pay rate? Say I made $15 an hour. And notice now I got my pay is $600. Another thing to notice is that here the cin will read the 40 and then pause, and then it will read whatever comes next in the next statement. So here it read, how many hours have I worked? 40. That stopped reading. And then the next cin statement went ahead and took the pay rate of $20 an hour to get 800. So you want to be a little careful with cin because if your user enters something with spaces, only the first thing before the spaces will be saved in that variable. Let's look at another example. So here's an example of cin inputting data from the keyboard. So notice we have three variables, v1, v2, v3. So it will read the three variables in order and then store them and output them back to the screen. So here I can go ahead and run this program, and you see Oops, I need to just change up here. I'm going to change it so that it runs my cin demo. And you can see, cin demo, I'll click run, and see now I'm entering 3 numbers. How about 1, 2, 3? Notice it will read number 1 and store it in V1. Number 2 is stored in V2. Number 3 is stored in variable 3. Notice I cannot just do 1, 2, 3 because notice 1, 2, 3 until it sees a white space, that value is stored in that variable. So again, one thing to note about cin and white space is that cin will keep reading until it sees that white space. So for example, here, if I had a string variable named name, and I enter my name, if I use just cin name, notice I stop reading after prof, and I enter just prof. So sometimes that can be a problem. One thing to be aware of is the C++ string package contains a function called getLine. And getLine can be used to read entire lines of text. You have to have include string here in order to use getLine. But if I notice instead of using cin name, if I use getLine cin name, then notice it will save the entire name including the space. So generally getLine is not used that often in this class. Typically, I only recommend using getLine in those rare cases when you do want to read white space in a name. And in this case, getLine will stop reading once a new line is reached. So here, it's waiting to see the enter key or \n. So the getLine will keep reading by default until the new line is found. All right, so last couple takeaways for today. Initializing means assigning a value to a variable. We'll learn later that if you try to use a variable that has not been initialized to a value, you'll get some errors. So, a couple ways to assign values to a variable. You can actually declare and initialize in separate lines of code. You can declare and initialize in a single line of code. Or you can also use a cin statement to assign a value. So any of those methods could be correct. So here we're declaring length, initializing to 12. Here we declare and initialize in one line. And here we read a length from the screen and store it in the length variable. Notice you have to have the variable on the left. So the value here is stored in the variable, so you cannot go 12 equals length. Must be length equals 12. One other thing to note, if you are declaring and initializing a character or string type, there's a small extra step. If you're initializing a character, you have to enclose the letter in single quotes. If you are initializing a string, the string must be enclosed in double quotes. So this is just a syntax requirement, so please be aware if you are assigning value to strings or chars, you need to follow these rules. Let's do a quick review question before we end for today. And so let's see how you remember declaring and initializing. Try this question, and if you'd like, pause the video for a moment. Then we'll discuss. Okay, so here we are asked, what is the correct way to declare a double variable called myNumber and set it equal to 5.75? Well, we always need a semicolon after our statement, so choice A would be incorrect. We need a semicolon. Also, notice we need to declare a double variable. So C and D are incorrect because we need to specify that it's double type. And in choice D, the ordering is wrong. Correct answer here is choice B. It uses the correct syntax, and it correctly initializes to 5.75. All right, so now let's revisit our original problem from today. We wanted to write that program which outputs the pay in dollars and cents. And as you saw, we learned that one possible solution would be to write something like this. I'd encourage you to try going back and remaking this program on your own in your IDE. You can learn a lot just by typing out the code and playing around with it. See if you can add some modifications. For example, one thing you might notice about this code is that if you have a very large number, you'll get multiple decimal places. And so a recommended fix is to use this include iomanip and cout fixed set precision 2. So what this will do is this will ensure that 2 decimal places are shown. Here we first tell C++ to display the decimal point and only 2 decimal places. So that we need iomanip to format decimal numbers. So real quick, just for fun, let's demonstrate this. I'll go back to my program in CLion, and let's try iomanip. Okay, so I've returned to my original example, and so here I'm going to add include iomanip. Remember, we need this to control the decimal places. And then what we can do is we can output fixed to show the decimal, and then we say set precision with 2, and that will ensure our total pay is showing only the correct digits. Let's try with and without so you see the difference. If we do not have the set precision there, notice if I work a lot of hours and I get paid a lot of money, I get scientific notation and a large number, right? And I want to see dollars and cents. I don't want to see $9.99999 times 10 to the 10th. So to fix that, that's where fixed comes in, to always show the decimal. And then if I do the set precision 2, notice if I rerun the program in the exact same way, notice now I get my dollars and cents, even if the number is very large. So this is just another way that you can use some of the tools we've learned to nicely format your programs. So I hope you found these examples helpful, and I highly recommend that you go back, try coding this up for yourself, and playing around with it. One of the best ways to get comfortable at programming is to sit down and write programs like this on your own. Verify that you're able to get the same result as we did. Once again, you should now be able to identify and explain the main parts of our C++ programs. Make sure you know how to apply proper syntax and best practices. And also, start getting comfortable with writing simple programs, using variables, inputs, and outputs, and know when to use the different data types. We'll continue talking more about this in our next video. Thanks everyone, and we will see you then.